Hello, everyone. Thank you for joining. Thank you for coming to this AI agent meetup today here in Paris. Beautiful day outside. Thank you for joining us here inside, indoor, for this conversation. I'm Agata Ferretti. I am the lead of European lead of the AI Alliance. Thank you. The background noise disappeared. So I'm leading the AI Alliance here in Europe, and I'm based in Switzerland at IBM Research. And my role is the one of coordinating the activities of the AI Alliance among members, partners, also contributing to organization of events like this one. And just so, let me see if yeah, works. So for those of you who never heard of the AI Alliance or have heard of it, but just passing, the AI Alliance started, and I will tell you a bit more in a second, but basically the idea behind it is that technology is really too important to be shaped by a few. The effort of building technology in the future from now towards the future is really to build it together, as it will transform our lives and next generation's life. And so we are all invested in it, and we should all contribute towards it. And so on December 5th, 2023, the AI Alliance was launched with 56 founding members. Among these, we have IBM and Meta, who were the initiators together with other 54 organizations. And the idea is really to bring together a community of innovators, developers, and also adopters of technology that are really bounded by the idea that we need to build AI in the open space. Open investments, open technology, open development. And so from those 56 countries, now we are 56 members, we are now 180 plus organizations, around 29 plus countries. As you can see, so the map is really small, I'm sorry, but we're trying to squeeze everyone in, and it's been quite a tough task, let's say. But as you can see from the color coding, basically we have enterprises, we have startups, we have NGOs, we have academia, we have, small, big companies. And I think this really shows that we need to work together, no matter, let's say, who we represent in terms of, again, stakeholders, right? With the idea that AI needs to benefit everyone. And so the only way to do it is together. And so, as I said briefly, the AI Alliance requires three pillars to democratize AI. One is to create a community of builders, those that build, release, and support open technologies in AI. Those that are enablers, right? So that they are those that enable developers and organizations to adopt open source technologies, including, of course, AI, and then advocates, those like me today, but all of you in your respective roles that advocate for a vibrant open technology ecosystem in AI. And so I just want to briefly to show you, we have different focus areas in the AI Alliance. Some are more technical, some are more related to policy or education. So I'm sure that if you visit our website, you will find some areas that might interest you and that relate somehow, some ways to your current work. So we have space for all of you to join and to contribute. More in detail, we have, as I said, areas that have to do with trust and safety and evaluation of AI, others that have to do more with building open source AI, others that have to do with hardware, others that have to do with data set and models. So there is really space for everyone. And so I recommend you to scan this QR code. We have possibility for all of you to join our working groups. We have many. And one of those is about agents and AI agents and AI foundations, and I'm sure many of you are interested in participating in that working group. We invite, of course, individuals to join, as each of you can join the working group, but also your companies or your entities you represent can join as members of the Alliance. The last thing I would like to show you is like this list of core initiatives that we have currently bringing forward, or we are currently bringing forward in the Alliance. And one of our main activities really relates to open source AI agents and application lab. In this activity, we want to build a sort of domain-specific lab for agents, right? Build and release reference architectures and components of AI agents, and also use and deploy different frameworks to create these agents. Also, our attention is on safety and evaluation. I don't have to explain to you, I guess, the importance of building taxonomies and references tags to evaluate and assess the quality and the safety, of course, of these tools, that AI tools and AI agents that we put out. And also, we are working more and more domain specific. So try to create evaluation and stacks for AI that is open source AI that is domain specific. Then another important area for us, and I'm sure for many of you working in this space, it relates to data. So we cannot do good AI, open source AI, without data and open source data. And so one of our key initiatives is really to create the largest open trusted data for customizing models in, again, domain-specific uses. And then also we are focusing on deployment foundations, so doing inference scaling and distributing multi-hardware. So these are our core initiatives. Again, if you check our GitHub page, we have different repositories with different projects and activities, so please go ahead. And now, without further ado, I would bring to the stage the first speakers of today. We have a very rich agenda, and I'm very pleased you'll join us. So thank you very much for being here, and I pass the mic to our colleagues for Econometrics. Thank you.
Hello. Does it work? No. Hello? Yes. Thank you very much for this great introduction. Very interesting. I'm Annabelle Blanchero. I work for Econometrics. We are at Econometrics. And we're going to tell you just a little word about us. We are what we call a scale-up company that builds AI solutions for different types of clients. We've been doing that for almost 20 years now. We've just been elected for the second year in a row as France French Tech 120, so for scale up. So very happy about that. We are a purpose-driven company. We have a mission to help our clients to be more sustainable thanks to data and AI. And I myself lead the responsible AI practice, trying to implement AI in a responsible way. There's a lot to do on that topic, and I also work in innovation. I'm going to tell you just a little bit more about that. We want to minimize the time between a research paper and its application in our solutions. So we're very oriented towards building things that are very applied to research science. And we also want to do it with the maximum of interpretability, robustness, and responsible AI by design. We have different research lines. And one of them, of course, is natural language processing and GenAI. And Jean is from this field of research. And we're very happy to share with you this project that we've done together on graph-based agentic RAG for complex real-world multi-hop reasoning. I'm going to explain all these words in this word salad. We did that in collaboration with INRAE. INRAE is the French Institute of Research on Agriculture and Environment. We worked with the Open Science Department of INRAE. So it's a department that's trying to bring value to all the scientific research that INRAE is doing, publications, projects, and so on. And the question we wanted to answer is, how do we get complex, relevant information from a very rich expert knowledge base? Where would we search for it? Yeah. Do you want me to do it?
Oui.
So yeah, so imagine that you want to find INRAE authors, scientific authors who have published on climate change adaptation strategies. But you also want to know what projects funded these publications, and also what other topics these funding projects also are related to. So we see that that's a multi-hop. We want multiple information about those. We want exhaustive information. We want all the published work on that topic, all the related topic, all the project that funded these publications. And yeah, where would we look for it? One classic thing to do would be to go, for example, on Google. But Google will give you some links, but nothing that is really relevant to the question you're asking. We can look on PubMed or any other paper-related website, but obviously that will not also give you an answer to your complex question. In this case, it just bugs. So it's completely unresponsive. ChatGPT, you can get an answer. Nowadays, it's getting better and better. Problem is, you have no idea if it's exhaustive. You don't know if it's true. There's a whole bunch of hallucination that can come in there. So you can't really trust it. So we have built a new tool that we called INRAE Explorer, and we're going to show it to you today.
So first, for a little bit of teasing, we'll show the application once, but really quickly. And then we'll explain how it works, and then revisit the application with the gained knowledge. So let me share with you. All right. So this would be, for example, one question we could ask the application, which is find INRAE authors who have published on climate change adaptation strategies, identify the projects that funded those publications, and then list other key topics these funding projects are related to. It's a very complex multi-op question, like Annabelle said, and also that require really exhaustivity in the search, something that you would struggle to obtain with classical RAG, in which usually you have like a top 5 or top 10 relevant paragraphs from your knowledge base, which is usually some raw text from PDF or Word documents. Here, as we are using a more structured data, we can explore the data step by step using the agentic capabilities of nowadays LLMs. So here we can see that the model look for a list of publications, then the authors of those publications, and then finally, and the related funding projects, and then finally from the projects goes to what are the related topics. We'll open the boxes at the end of the demo to show you exactly what's in them. For now, we'll go back to the presentation. Just a second. So first, we will talk about the data, which is the base of any retrieval-based application. This is the interface. Yes, first the data. First data source was tabular data. We were looking for databases that have lots of meta information about different scientific publications. So OpenAir is a public one, ALINRAE is public too, is from INRAE directly. And then we merged them in different ways, mostly on DOI, which are the identifier for scientific publications. And then we had all metadata information about those papers, so title, a list of author, abstract, language, date of publication, and so on. And then, as we filtered only on open data articles, we were able to download the article as PDFs and then extract the whole text of the PDFs using a tool named Grobid, which is made to extract very formatted scientific articles. And so we had access to the full text of the document. We used part to link it to the INRAE thesaurus, which is a big, like a big dictionary with main domains and then subdomains and sub-subdomains to the leaf of the tree are concepts, which are a word with a definition. And we used matching to find in which documents we talked about here, for example, biodynamic agriculture, for example, and there were like about 15,000, I think, different concepts from this thesaurus. So these are lots of data that we try to aggregate into one in a knowledge graph. So it's very publication centered, but here in red, it's a bit small, but I will talk you through it. Here in red is the publication, and it's linked to the keywords, which are the author declared keywords when a scientific publication is published. Then projects are who is funding the thing. Data set is which data is used when data is used for the research. Concept and domain are from the thesaurus. Journal is where it's published. And so on. Research unit is where the researchers are from. So here are the exact count of each node and edge in the graph. And we put this knowledge graph in Neo4j to be able to easily query it. Here it's an extract from the graph to show you with real examples. Three authors and three keywords, three concepts, so on. And now, how concretely can we have the agent querying the graph? Well, there are four tools that the agent has access to. One which is the knowledge graph query, which is the main tool of the agent, the main way to interact with the data. For example, if we have one query like that in a natural language, we can reformulate it and transform it into a cipher query, which is the equivalent of SQL to query graphs in Neo4j. And we get a result with here a table with authors and how many times they co-wrote a paper. So concretely, the agent has access to this tool in which the user speaks in natural language, then the model writes the cipher, and then Neo4j gives the answer back to the agent. Then we need ways to find entry point into the graph, because here, for example, we don't really show it, but you would need to have some IDs or ID literally to be able to access the graph. So one way to do that is to give the model a tool to with natural language have different IDs of different publication. Here, one way to do that, that is the main state-of-the-art way currently, is to use hybrid search with combining the strengths of semantic search, which is creating an embedding of a chunk of text. Here we chose a concatenation of title, keywords, abstract, introduction, and conclusion, as we have access to the full text of each scientific article. So we created an embedding of this that we use with cosine similarity to find the closest semantically paper from a query. And then we also use keyword search with BM25, which is just a way to find how many words are in common between a given query and a chunk of text. It's very complementary because one is really good to find the meaning of the sentence, the order of the words and the synonyms and so on. And the other is really good to find like a very technical vocabulary that the embedding model hasn't seen in its training data, or even like proper nouns or things like that to match exactly one word. And then we use a re-ranker. I didn't add it, but we used the model from Cohere. And also, everything you will see here is open weight or open source, usually open weight. So the re-ranker was the model from Cohere. Semantic search was with Gina v3, and keyword search was BM25. We used Qdurant as our vector database. Okay. Here for concept search is the same ID, but we use the simple Levenshtein distance to find the concepts that are closest to a given word. It helps with finding like a concept, and then as we did the matching with the full text of the document, we can do in the other way, and with the concept like animal disease or agriculture or so on, find all of the papers connected to it. Those two are great for the model to find entry point into the graph and then begin doing cipher queries to use those entry points to unroll the truth. And here we said, now that we have 3 tools already, the good thing in this approach is that it is very modular. And then we can create any other tool that we like and add any domain-specific knowledge that we want to add. So here we created an expertise score from how many publications did the researcher publish on one subject. Was it cited a lot, and so on. So you can see all the different arguments of the function that calculate everything here on the left. I can come back to it if we have more time. No, I will show you the most important part. I will open all the boxes in the demo. So here, when we ask find the author, find the paper, find the project, then from the project, find the related topics. First, the model will do a publication search to have its entry point into the graph. So here the query is time strategy. It will do the hybrid search like we've seen just before. And then the results look like this, with a title, a similarity score, and most importantly, an ID corresponding to the node in the graph. Then using those, it will query using Cypher, using those ID that you can see here. He will use it in the next call, and then he will begin to unroll everything it investigate for. So the different IDs, and so I won't decipher the cipher, but the idea is
to
to find
the
the
different
different
authors.
authors.
And
Using
this second result, it will
it will
look
look
for a
for a
third one, which is the different projects, and then the concept related to the project. Here, because the agent is really intelligent, it's the new R1 from DeepSeek. As it's really intelligent, it can do several steps in one tool call, but this for a simple agent would have been like a 5 or 6 tool call, because here, for example, as Cypher is very powerful, you can do several embedded call inside of each other. So the results are here the different projects and the different concepts related to them. And then it will write the results, and we can continue to interact with it. Another example we wanted to show you was a much more simple one, where it will use the tool we created with expert identification. Here it will just look with one query, but on the back we hard-coded several uses of our vector store and several already written Cypher query to create the expertise score and organize the results. So in a way, it was to show that as it's really modular, and the results are like this, as it's really modular, you can really add any tools that you want to add, and add the logic from the domain specific that you want to. So here, for example, we created it with the client. So I mean, with InRay. So you can really create anything from base tools, or you can just let the agent create everything with its base tool. It's two main approaches. You trust the agent very much, or you want maximum reproducibility. Reproducibility? Yeah. Sorry. Yeah. And I believe that's it. Thank you. Thank you for attention. I don't know if we have time for a few questions or if we go directly to 5 minutes. Yeah. So do we have any questions in the room?
How are you evaluating the results?
A great question, the best one. Yeah, we didn't have a lot of time to do this project, so it's the next step, but we weren't able to have clean evaluation right now. In practice, it's better, but it's much better in the sense that the question that we ask the model would be impossible to answer for a classical RAG with like one call and no agentic behavior, no structured data, and so on. But we didn't had the time to have like a clean benchmark results or things like that. But yes, of course, it's like our main priority if we continue on this project.
Yeah.
Thanks. How do you match the documents with the lexical tree?
Yeah, it was very simple. We used Spacey with like uncased, and then we just limitize the word, get rid of the stop words. A very simple exact match with like a little enhancement. But yeah, as simple as that. The complicated thing was we didn't want to match it with the whole text of the document, because sometimes a concept is we talk about the concept in the paper, but it's not about that concept. So we really had to debate on, do we put the conclusion in it? Do we put the introduction in it? So there was a bit of fine tuning on this part, but very simple exact match algorithm. Yeah.
Thanks.
Last question, I think, before the last.
Thank you. It was a really interesting. I had a question about the hybrid search. If you could go back on it, I didn't completely understand how it was done. Thank you.
Yes. So, okay, I can re-explain. So there are three parts in the. There are two types of search that we use concurrently to get top 50. Here we chose 50, but you can use 70 or that are complementary. One that is very specifically designed to try to understand and represent the meaning behind a paragraph of text. So it creates a vector in a latent space, which we call an embedding, which is just the representation of the meaning of the text, and then we compare it to the meaning of the query of the user. The thing behind it being like, if it talks about the same subject, then probably it's useful to answer the question. And the other one was just keyword search with a little bit of some kind of TF-IDF, which is called BM25, which is a little better than TF-IDF. And so we take the top 50 of the two, we merge them. So maybe we will have like 70 results because some will be in common between the two. But we'll have the strengths of the one and the strengths of the other. And then we use a re-ranker. Here it's called the B encoder because in advance you can compute the different embeddings. And then at inference, you have to compute only one embedding. So you can scale it really well, like with millions, billions of documents. And then here we used what we call a cross encoder, which is a model that takes the query and the paragraph, and you put it in a neural network. So it's much harder to scale because you have to do one pass in the neural network for each document you want to test. So we only do it on the previously selected 70 or 80 documents. And then using this very powerful model that is from Cohere, but you have other model, open weight on Hugging Face that do the same thing. We take the top 10, and for this top 10, we give to the model back the title and the ID and the similarity score. And if it requests it, the full text of the chunk that we used here, which is title, abstract, introduction, conclusion. Thank you very much.
Test. Yeah, perfect. Thank you so much. Great presentation and great questions. So we are moving on with our program and presentations. I'm welcoming to the stage Thomas Bratanik from Neo4j, which is another member of the Alliance since the beginning, I would say. And so thank you, Thomas, for explaining us a bit more about the agentic graph RAG that you have been working on.
This is French. Basically my name, right? But no, Latin is .tom@gmail.com. No, yeah, Tomaz, gmail.com. this. Okay, okay. Let me share screen. Okay. Hello. Echo.
Just
Uh-huh. Okay. Yeah. So hello. It's actually my talk will be very similar to the previous one, just a little bit more theoretical, and unlike the previous one where it was like a biomedical domain. Okay. So my name is Tomasz, and today I'm going to talk about agentic RefRec. And as I whispered before, my talk is going to be very similar to the previous one, although a little bit more theoretical and focusing on legal domain and not biomedical, because legal usually works better with mainstream audience. I also wrote a book that's coming out in 2 weeks, hopefully. But now let's go straight into the topic, right? So LLMs are really awesome when they work, right? They are quite magical, and you get a lot of aha moments or like wow moments. But then, like when you're doing a demo to your boss, suddenly it starts working, right? And you're like, wow, what should I do now, right? And it kind of turns out that LLMs, neo-today people they call it, LLMs are only working with the right side of the brain, which is kind of the imagination and art, and they don't work so much. They don't work so well with logic, mathematics, or facts, unfortunately, because kind of LLMs took the cool jobs away from us, and they leave us to do the hard work, right? But the nice thing is that there is a solution, and the solution is the agentic approach. And with the agentic approach, as was shown before, the LLM, basically the idea behind agents, at least in my mind, is that we give some tools to the LLM that it can use to interact with the environment or use it to fetch additional information, as we saw just a second ago. And it can do like multi-step reasoning or planning and execute upon it. So it's quite powerful. And most of these abilities come out of the box when you're using the more powerful LLMs. And if you look at like a simple like agentic framework, what you have is you have your LLM, which is like the generative AI model. And then you give it some set of instructions and goals. You can also give it short memory if you want. But for me, the most important, or like the most kind of magical thing about agents is the tools, right? And then, because this is basically where the LLM can interact with the environment, and it can use the tools. It can use the tools to get. Yeah, okay, I get it.
Thank you.
So the tools is where the magic happens because they allow the LLMs to interact with APIs, databases, other agents, and so on, right? And since this is very mainstream at the moment, we kind of saw people kind of saw that there's like a lack of standards, and I can't see it. And basically, a lack of standards, right? So anything you want to integrate into the LLM at the moment, you have to do it on your own, right? That's quite unfortunate. And then basically anything that you do, you kind of have to learn on your own. And that takes time and limits basically the agents and also your ability to solve tasks, right? And basically the solution was, at least now it seems that the MCP, the Model Context Protocol, is kind of the solution to the standardization of the tools. So in my mind, basically how I see it is that you can see that nowadays, basically any company is offering APIs to interact with the data, or like do some sort of interaction with that particular company. But now with the rise of agentics, we kind of want to allow LLMs to do some things for us, right? So my prediction, I would say, like in 6 months, basically most of the companies will kind of have an MCP server, so like standardized, basically you can call it like an LLM interface, right? So the MCP is just it's like a simple wrapper around your API, because nowadays basically every company has their own API. But if you want to use LLM to interact with the API, you kind of have to implement the logic on your own. But hopefully, in a couple of months from now, companies will basically do the implementation for you, and you will just connect to their, as we will see, to their MCP server. And so you can avoid implementing or integrating all of the services that you want to provide your LLM to interact with, right? So the MCP architecture is quite simple. You have a MCP client, so that's basically your user interface, where the user can talk with the LLM, and then kind of the tools are exposed as MCP servers, right? So basically, a company will have an MCP server. You connect to the MCP server. The MCP server returns which tools you can use, or basically which tools the LLM can use to interact with the API. And that's basically it. And then the LLM can handle your request, translate it into the MCP server, and then you can do like read-only operations where you get some information back, or you can also do some write informations if you're courageous enough, right? So that's kind of how I see it. Basically, is that MCP is just an API that has a description for the LLM how to use it, right? It's no rocket science. It's just that until now we didn't have any standards, and now this is kind of, it seems, the most mainstream standards that a lot of big tech companies have adopted. And hopefully, in a couple of months, a lot of these tools will come out of the box, so you don't have to implement everything on your own, right? But then what you will still have to do, you will still have to build tools for your internal databases, right? Because you don't want to, let's say, if you have your internal databases like user databases, product databases, you don't want to expose that to the internet and have someone else build the tools for you. You kind of want to build the tools on your own, so you handle the whole flow and you handle the security and all of that, so it's not exposed to the internet, right? And when, at least what I see, mostly when people are talking about tools or like retrieval with LLMs, a lot of people think about vector search, right? Because that's kind of the hello world of AI, is basically chat with your PDF, right? You take a couple of PDFs, chunk them up, index them in a vector database or a vector index, and then at query runtime, you use the same embedding to embed your question, and then compare the embedding of your question to the embedding of the documents, and then return the top 5, let's say, usually it's 4 or 5 top relevant documents. So in this case, like, the data model is very simple. Here we're now moving on to the legal domain. I mean, if you look at the legal domain, basically you have a contract, you chunked it up, and then each chunk has text and embedding, and then at query time, you just retrieve relevant text chunks, hope the information is there, and that's basically it, right? That's kind of the basic approach. Now with legal, there's like a bunch of problems here. like, so for example, if I would ask, like, what are the payment terms for license agreement with whatever company, if you're just doing vector search with no additional operations, while the semantic search or vector search might find chunks that contain information about payment terms, it doesn't necessarily mean that the payment terms are from your specific contract, right? So that's a big problem. And then the other problem is more like technical. So I don't know. Okay. So there's also the limitations of text embeddings, right? Because, for example, text embeddings just kind of look at similarity between text. So if you want to do some, in this case, like additional filtering, like in the previous example where we wanted to filter for specific companies and their payment terms, basically, you cannot do this only with vector search. You need some additional properties, and this in like vector space or like rec space is called like metadata filtering. So that is one thing. But then, like for example, in a legal, if you would want to ask like how many active contracts we have with Apple, right? Because that's like a really valid question. There's no way to answer that using only text embeddings, right? Because if you use text embeddings, you'll just get top 4 relevant text chunks, right? And if the information that you're looking for is not kind of pre-computed and stored in text chunks, then you aren't able to answer that question. And the same goes like if you want to sort or if you want to do any aggregation, right? And basically what I've showed here is that the 4 types of operations are what I call them structured operations, right? Because what you need structured data, right? Because what I see in LLM space or X space, everybody just talks about documents and embeddings, but a lot of people forget that there's this realm of structured data like JSONs and CSVs that can also be used to answer questions, right? So, for example, if we expand on the legal model, so let's start with a very simple model. We have contract and text chunks. So now let's do a little bit of NLP, so like structured data extraction. And for example, we can enrich a data model. We can add which parties are involved. We can add the start date. We can add the contract type. And but we don't have to stop there, right? We can then go and connect amendments, because when you're answering questions about contracts, it's very important to kind of also include amendments, right? Because if you're not including amendments, you're not getting up-to-date answers. And this is kind of like the NLP part of the world when you're extracting structured data from text. But it doesn't have to be only extracting structured data from text, right? You can already have some structured information in your user database, product database, or like CRMs, or it can be like third-party enrichment APIs that you can use. And for this example, we maybe added like the CEO of the party, or like, so maybe you know who to invite to dinner when you sign a big contract, or like you know where that company is located in. But basically what you end up with is like a knowledge graph, right? Because this is basically a knowledge graph, right? Because we have nodes. So nodes represent entities like contracts or parties, and we have relationships between those, right? And I have a, and now that you kind of enriched your data model, you can ask or answer questions that you couldn't answer before, right? So for example, if you ask which of our clients has the most active contracts, you couldn't answer that with just basic vector search, right? But now that you nicely structured your information, this is a very easy question to answer. And I gave like a couple of examples. But for me, what's nice about knowledge graphs in particular is that we have, excuse me, explicit links between the unstructured part of your data and the structured part of your data. And what this allows you to do, it allows you to do also precise metadata filtering, right? Because since you have both the structured and unstructured data, what you can do, you can narrow the subset of the chunks you want to kind of search through using some sort of structured data. So for example, we could say inspect only the contracts that were signed with IBM, or like companies that have revenue over 5 billion, and then check and then search for the information using vector search, right? So kind of the metadata filtering is basically it's called when you first do some sort of structured filtering and then apply vector search upon it. So basically you narrow the set of documents you want to search through. But it doesn't have to be just that. What you can also do, because like when you chunk up a legal document, like for example, a lot of legal documents have some definitions at the start. So for example, who are the parties involved, or like employer, employee, how the references will be used. And then like throughout the contract, you might just see employer and employee, but you won't know the exact name of the employer, employee. But since you have that information nicely in the and nicely extracted and connected, what you can do, you can also just do vector search, and then along with your text chunks, you can also return the definitions, because for example, here you would have the involved parties, and it could be much more, right? So for me, these explicit links between structured and unstructured data opens up a lot of operations, or basically it allows you to answer questions that weren't kind of possible before, right? Yeah, so knowledge graphs are really good at representing heterogeneous and complex connected data. But now let's look a little bit at how to implement. Now we kind of talked about constructing the knowledge graph. You can combine a lot of data sources, both structured and unstructured. But now let's talk a little bit about how to retrieve information from knowledge graphs, right? So here we've kind of identified 4 different types, and I will just briefly go over the 2. So the first one is the text decipher, which the guy before me said it's a knowledge graph tool. And then the second one was the graph filtering, which I will just show in a second. But basically, the idea behind text decipher is basically you give the LLM the schema of your knowledge graph, and then you ask it to generate a cipher statement to find relevant information that could answer the question, right? So if we have a knowledge graph with movies and people, and now we ask it how many actors appeared in Top Gun, the LLM nicely constructs a cipher statement that can answer this question. Now, the only problem is that since text decipher is really awesome and it's very flexible, it comes at a cost that it might not be the most robust thing, right? Because there's like a lot of moving pieces around text decipher. So like what happens when you ask an ambiguous question? What happens like when the user vocabulary doesn't match exactly the database vocabulary? And but basically there's like a lot of kind of open questions that we're trying to solve. So the flexibility of text decipher is really nice, but it comes at a cost. And then on the other side of the spectrum, we have the graph filtering pattern, what was in the previous talk called like identifying experts. So in this case, you have like the subject matter expert implement a tool And then basically, yeah, the subject matter expert defines the code that generates the cipher statement, right? So in this case, I wanted to build a tool that finds contracts. So I gave the LLM the attributes. So the attributes are exposed to the LLM, what it can use. And then the LLM only needs to populate the attributes, and then the kind of logic or the cipher generation happens behind the scenes. So in this case, we take a lot of complexity away from the LLM, because now the LLM doesn't need to know that it's dealing with a knowledge graph, that it needs to construct a cipher statement. It only needs to know that basically it needs to populate the attributes accordingly. And since we took a lot of complexity away from the LLM, in return, we get a much better robustness and accuracy. But obviously, it's limited flexibility, because we kind of have to predict in advance what types of questions we want to ask, and like what's the information needed to be returned. And I kind of see it like as a spectrum. So on the one side, you have very flexible tools like text to cipher, and on the other hand, you have like very constrained but more robust, like the graph filtering tool. And for me, basically, where you want to be is probably somewhere in the middle, right? Because you don't want kind of the LLM to just do whatever it feels like, because then when you're doing demos to the CEO, it will just decide not to work. But you still want to be somewhere in the middle, because LLMs are still like powerful tools, and they can do a lot of great things, but just not everything, right? So it's kind of, you want to be kind of somewhere in the middle. And because we started with MCP tools. So Neo4j developed 3 MCP tools at the moment, and they are more on the generic side, right? Because otherwise, it's kind of hard to build generic tools if you don't have like a generic approach. Because like if I build like a custom tool for my database, it's not really reusable, right? So we started with generic tools. So we have one MCP tool for basically text to cipher, so converting natural language to cipher queries. We have another tool that can store information in Neo4j, and then the third one is basically like an DevOps API, which is just there for fun. And that's basically it for my talk. And like, if you're interested in graphs, we have a free online conference in November. And as I saw today, the call for papers is just 2 days from now. So if you have any interesting talks you want to present, you can still submit your papers. And that's it for me. So now if you have any questions, I'm happy to answer them.
Thank you, guys. We are a little bit out of time, so maybe we will take one question, and you guys can save the rest for the cocktail, okay? Does anyone have any question? Aside from Jean.
Thank you so much for the talk. My question is about how do you manage to keep a control of the context length when you give the full documents added to the chunks of text?
For legal, it depends. Like, it's very domain specific, because you can have like contracts that are 1,000 to 2,000 tokens. So in that case, probably you don't need to chunk them up. But like if it's larger than like X, so for example, it could be more than 2,000 tokens, then you need, or at least it's kind of advisable to start thinking about chunking. I mean, LLMs can handle a lot of tokens. You have LLMs with 100,000 token limit. So in theory, all legal contracts are less than, let's say most legal contracts are less than 100,000 tokens. So it's less of a problem than in some other domains. but it's still something you kind of have to think a little bit about.
Thank you so much for your talk. We move on to our next speaker. And again, sorry, in the interest of time, we cut it short, the questions, but if you guys stick around for the upper, we can, and a happy hour, we can, you can ask the speakers your questions. So we move on to with Diego Costa of Mistral, and he's talking or providing a talk about agentic workflows with Mistral Agents API. So thank you very much.
Bonjour. Okay, perfect. So, hi everyone. I'm Diogo, so I'm from Mistral AI, DevRel team, and here I'm going to present you mostly our agents API. I hope everyone knows about it, but yeah. Okay, so we have been releasing a lot of models, services, and, well, a bunch of other things. Lately, maybe you heard about Magistral, but today we are going to talk about something released like 3 weeks ago, and it's our brand new agents API with a lot of features. And we are going to mostly talk about them and also show some examples and demos. And if you guys have any questions, you can. Closer? Yeah, I will try my best. So, what are you going to say? Yeah, regarding what are you going to present? So a bunch of demos and what you can do with our agents API. And I think we can just go straight to it, and we can. Yeah, so we are going to talk mostly about agents. Also mention them on SHA. So it's our chatbot interface where you can also create agents there. And then we are going to discuss mostly the API, the conversations, tool aspect, the tools, connectors, MCP server that was introduced just before, and some agentic workflows that you can create and make your own based on our models, agents, and the handoffs feature that we are going to discuss. Skip, I think. There you go. I think everyone already knows what an agent is, but why not just introduce a quick definition so we are all in sync? I think it went too far. Thank you. So basically, everyone knows that an agent is basically an autonomous software entity. It has access to a bunch of things, mostly tools, but it has also an environment that it will work with. And then we need to consider every single aspect when making an agent, specifically the use case that it will have to respect the most. But there's also the fact that we need a bunch of tools, and it's one of the aspects that people will take the most time with, since it's not easy to have the correct tool and provide it to the model and have the correct instructions for it to actually follow those instructions. And of course, having it all work extremely well with the environment it is in. At Mistral, we try to provide the best models capable of the agentic capabilities, and we are talking about, of course, the tool use aspect, but also about following instructions properly and all the environments. And we are also providing a few tools and features that you can use to build them. So regarding the SHA, basically it's a chatbot interface, and you can now create basically extremely easily friendly some agents with some instructions. And the advantages is that it's extremely customizable. You can share it with your organization. So if you have a big organization with a bunch of people, you can create an agent and share it with everyone. It's extremely user-friendly, shouldn't be too hard. And there's a bunch of tools that you can use already built in. So it's really easy to just make your agent with a bunch of tools. And you can also extremely even add new tools with connections. It's what we call. We also have what we call the SHA Enterprise that basically allows you to also have some more custom connections with custom tools that the agents can access. There's also the tone and guardrails that you can add, instructions, and the test playground. It's just extremely easy to edit the agents directly. Now, regarding the API, it's the main topic here. There are 4 aspects that we are going to discuss, basically. We have the agent's creation, everyone knows about it. And then we have the conversations API. It's where basically the agents will interact. It has all the entries, all the history, and every single action that the agent will like. And we have all the tooling with all the tools that the model will have access. And then the workflows. It's basically provide a handoffs feature that allows agents to call other agents. We're going to dig into it later. But yeah, we are going to discuss these 4 main topics. Our ecosystem basically is all around the conversations API. And you have all the features that are available with the chat completions. So we are talking about structured outputs and so on. But also another new feature, like you can actually store the conversations. So you can actually keep track of them more easily. You can retrieve them, you can restart them at any specific point, and you can monitor them way easier like this. Then you have the agents aspect, so you can have your custom instructions, you can update them, you have all the completion arcs, you have a bunch of features, and of course you can define workflows. And again, we are going to discuss it, but it's basically the handles feature. And then we have all the tools. We have 3 main things about the tools. I would say it's 2. We have the connectors. It's web search, code interpreter, imagination, and document library. And we were planning to add more tools, but basically it's built-in connectors that you can just extremely easy toggle and use them as you wish for your agents. And then you have function calling. It's the most classical way of doing tool use. And you can just define your own functions and run them like this. And then we have an MCP compatible SDK that you can just, it's already the same SDK. It's really built in, and you can easily have MCP servers as tools directly. I want to dig a bit more on the conversations aspect, because when we say a conversation, it's kind of vague, like it can be a lot of things. So what exactly is a conversation in this context? We have, of course, an identifier, so we can keep track of all the conversations, and an agent can create a bunch of them. So it's really important to keep track of them. And then we have the information regarding this conversation. We are talking about the name, description, when it was created, if it was updated, and we are also going to talk about the agent that created this conversation that we started with. And it can be an agent, but it can also be a model directly. Since it's completely compatible with the chat completions, if you don't want to create an agent directly and you just want to use a model with instructions, you can do it also. Then we have the entries. It's basically the history of all the events and what has happened in the conversation. We have, for example, the message input, the output, so the answer of the model. Then we can have another input or execution, but you can also have function calling, handoffs, and so much more. Regarding the tools, as mentioned previously, you have 4 connectors. So web search, we also have a small premium version where basically you have an integrated news provider with the verification. And then you have code interpreter, just an environment where the model can run code easily. It's really handy, and we'll talk about it too. And then image generation, it's just enables the model to generate some images. and a document library where basically you can provide documents and the model will have access to a tool to search on those documents with basically some RAG. Then we have the function calling. It's the most classical way, everyone knows, and you can just define your own functions on your own, and you can provide the model with the answers and basically the output of the function, and it will use it to answer any question. And then we have the MCP compatible SDK to easily be able to scale to the diverse tools that will be available out there. Now, for more details regarding the connectors, web search is amazing if you want to ground the model, if you want it to have access to brand new information, but of course it also has some issues. For example, we are talking about the internet, and internet has a lot of information and also a lot of misinformation. So it's important to have this in mind. We cannot mitigate this with some premium version where you have a news provider verification to have more reliable news. But there is also the issue with crawling, because not all websites will allow the bot to crawl them and to provide you answers from those websites. And if you are unlucky enough, your use case may require specific websites that have a lot of information about the topic, but will not allow you to crawl them. So it's important to have this in mind when doing an agent with web search, that if your use case specific has some websites that won't allow it to crawl, you need to actually take a look and see if you shouldn't change your method or way you're creating your agent. And you have code execution. It's perfect for mathematical tasks and for graphs. Like if you have some data and you want to quickly plot a graph, quickly interpreters is really nice and really handy. Of course, it has some issues also, because if the task you want to do is extremely complex, if it's a complete full app, this won't be your solution. Since code execution is for more general code execution and not really to do entire apps on the entire environment. Then we have the image generation. It's just a quick, easily accessible way of generating images if you require, but it's a disconnected model from the vision model. So if you want to, for example, modify an image, it won't be able to. So it has some downsides also. And then we have document library. It's a better feature. And basically, it has mentioned, allows you to upload a bunch of documents that you wish, and you can easily search any information on it. It's perfect for grounding the models on your own data, and there's very little downsides to it. And then we have MCP that was discussed previously. I think it was already done a good job at introducing it, but we are talking about standardized integration, so you can have a really easy way of implementing your tools, since every single MCP server follows the same protocol by definition. And then we have an enhanced security. It's very easy to scale, and it's also being adopted by a lot of people right now. So it will make it way easier to have access to diverse kind of tools for your agents. Now, the handoffs. Took a while, but we are here. So basically, it is a tool that will allow you to have different agents and make them interact with each other. And how they will interact with each other, we are talking about sharing a conversation with another agent that may be more suited to solve the task. And then that agent will decide what to do next, if he wants to answer the task, if it wants to hand off to another agent, and so on. Here we have a quick example. Basically, we are going to go through all the steps. The first step is the creation. That's quite intuitive. You are going to create your agents. Every single agent will have its own instructions, its own model, and its own tools that it has access to. Here we are going to go with a very simple example. So we have 5 agents. Every single one has a task. We have the first one. It will be like the general agent, the first one that we will call. And then we have the more specific ones. We have one that has access to some information about the European Central Bank, another one that has access to web search, and maybe another tools to search for news or something. And then we have a graph agent that can plot things, and then a calculator agent. These are very simple examples, but we are going to through step by step. So then the next step is to orchestrate. We are going to basically tell the model, tell the agent in this case, what are the agents that it has access to if it wants to hand off a conversation to it. So we define every single handoffs that it can happen, but of course the model can also just not do an handoff if it wants to answer directly. Now here we are going to start with an example. We have a quick question for the agent to answer, and here it decided to provide the conversation to another agent. It doesn't mean it didn't try to answer. In some cases, the agent will try to answer and then decide again to hand off still to another agent, because maybe it can do half of the work, but it's not finished, so it will hand off to another model to finish the task. And then once everyone has done his job, the final agent, maybe it's convinced that it's done, and it can provide the answer to the user. We are going to have a quick demo because this is something that we actually did. And here you go. Basically, we have the question. We have all the steps here. We are going to show later also, but we have all the steps that are happening. It tried to answer here, but it didn't have the complete answer, just how much was the interest rate. And then it continued and plotted what we asked. Here it was a very simple example, but it's just to show how it works. And here we can see step by step, basically. We have the agent handoffs that was here, the function calling that was here. Then it tried to answer here. It did the handoff there. And finally, it tried to execute the final tool. There you go. And it answers after. We have a bunch of other demos from different examples that the team did just to provide different use cases. Here it's connecting to an MCP server. So you can actually connect up to any MCP server really easily, and then you can just ask whatever task you want to do. In this case, it's a GitHub PR, and it will just create a PR and so on. All the demos that we are going to show just next, they all have their own QR codes that you can just check the code directly on our GitHub. So yeah, we can go to the next one, I think. Here is a linear ticket. So if you want to automate some of your management, why not? But yeah, basically it allows you to create some linear tickets directly. Then we have a financial analyst that is really similar to the previous one, but with a bit more details. And then we have the travel assistant. Basically, you can do anything you can think of with a bunch of agents, with different tools, different system prompts, and so on. So it's really nice. So all of these are cookbooks that are available now in the GitHub that you can take a look. Yeah, I hope everyone enjoyed. I tried to be concise and say everything I wanted to. Yeah.
Thank you. In the literature, there are many explanations about the architectures of agents, but in those frameworks, there are also components which are LLMs, and I would like to know how they are trained.
In general, how LLMs are trained, or
maybe like the orchestrator or some other agents, are they trained specially for some tasks, or how do they specialize?
Okay, so we did release a few models that are specialized. Can you go back to the timeline? But yeah, that's something that happens a lot actually, where you maybe either the general model is not good enough for the task that you want to, or just maybe it's overkill in the sense that it's way too big for the simple task you want to do, so you want to optimize better. But yeah, we do release some specific models. One that I want to mention here is DevStroll Small. It was basically a model that was trained specifically for agentic tool use for software use cases. So basically it was specifically trained to work with a framework that allowed him to try to do PRs, access code, and so on to make apps. So it was specifically trained for this kind of use case. And we do release a few other specialized models like this. Like there's CodeStroll 2, that basically is a coding model, but also for fill in the middle, so it's more general a bit. And then we have Mr. Saba, that was for specific languages. If your agent is very specific for a regional zone, maybe you want it to be really good at one specific language. And we also train these kind of models. But yeah, in general, you can always try to take a general purpose model and fit it for your use case, but it's really likely that you can get a way better result if you try to train or fine-tune a model. And fine-tuning, it's accessible if you have the data. That's the big problem. But usually if you have already a product, it's already working, usually you will get data from it and you can use it to simply fine-tune a model. If you want to fine-tune it, it's not extremely complicated in the sense that there are a lot of tools out there to allow you. We also provide a fine-tuning API where you can simply provide the data and fine-tune it for use case and then use that model as you wish. But yes, if my answer, I would say it's, yeah, usually train the model specific for your use case if you want to really optimize it as much as you can. Did that answer or? Okay, yeah?
Great. Thank you so much. Thank you for the talk.
No problem.
Now we're moving to the last presentation of the evening, just in between now and the happy hour time, so be concise and effective. And I welcome to the stage Joe Olson, who is also a member of IBM and a core member of the AI Alliance. And he will talk to you a bit about his lesson learned, or more broadly, I guess, AI Alliance lesson learned on the agent development lifecycle.
Okay, is this on? Yes, it is. Okay, I'll be very brief because I'm not one to stand in the way of happy hour. Skip this, skip an introduction. All right, I'm going to give a quick rundown of all the agent projects that are currently going on the AI Alliance. I think this works better. All right, I'm going to go through a bunch of open source projects that are currently being sponsored by the AI Alliance. So when you're looking at these, think if you want to contribute to an open source project and you've never done it before, these are good places to start. And it doesn't mean you need to code. There's plenty of things to do for non-technical people for contributing to open source projects. You can do documentation. You can do advocacy like I'm doing right here, to get up and talk about something. There's plenty of things to do. So if you don't think your skill set aligns with some of these things, put that aside and consider contributing what you do know to these things. All right, since this is a graph rag meetup, the first one I'm going to start with is this one called BartleBot. This is probably the hardest core graph rag project we have in the AI Alliance. It's run by a Stanford graduate, and he's building a legal graph rag, a very intricate legal graph rag that will be used for agentic applications. So the only problem is it's built on US case law, and this is obviously Europe. So the play here might be if you want to adopt this to the continental Europe case law, that this would be a possibility if you wanted to contribute to something like that. All right, another one is computer intelligence. This is run by a gentleman in Sydney, a PhD in Sydney. He is very ambitiously trying to streamline data collection and agentic workflows to automate things that are normally done on a computer via forms and user interfaces. So another project that we're working on. OpenSSA is industrial AI. So this is think manufacturing, think heavy industry. If you're interested in applying agents to heavy industry, OpenSSA might be an appropriate project for you to contribute to. And then finally, GoFanon. This one is a tool repository. So everyone is involved in this is writing tools into a main repository that we can then wrap with MCP or whatever we want to wrap it with in order to turn it into an agent. All right, now I'm going to talk about Open Agent Lab here. I'll probably skip the demo. We'll do the demo afterwards if anyone wants to see it. But I'm going to talk a little bit about how we've developed some of these agents. So this was a slide we showed in January of 2025, which is now woefully out of date. But this was the first agent we created and we roadshowed to explain to people what an agent was and how to deploy it. And all this agent was tell me when the International Space Station is going to pass overhead. That's all. Not very complex. It didn't take any parameters. There was no authentication. There was not multi-agent. This was January. It was very early on in MCP. So we didn't use any MCP things for this. We just wrapped a tool and we explained what we did. So this was 5 months ago, and I'd be embarrassed to show this slide in a current agent presentation, but this is where we started. Shortly thereafter, we wanted to build a more useful agent rather than when the space station, just for demonstration purposes, when the space station is going to pass overhead. So we got another ask. Someone came up and said, we want to build an agent that would help us apply for grants. And this would be a very effective agent because there's obviously money involved if you're applying for grants. So the ask was, we want to build an agent to help us apply for grants, and we want to be able to find other people to grant match with. So maybe we can't apply for the grant ourselves. Maybe we need to collaborate with somebody else we don't know in order to apply for this grant. So the requirements here are very basic. Find out what a user or organization's capabilities are. Find open grants that a user or organization that meet the requirements, and then suggest to others, suggest others to partner with. So we immediately started working on this without thinking, and this was pretty much the pipeline we developed. So gather requirements, we do the tool development, and the tool development is basically using a couple APIs that are out there. One in the US where you can search grants using an API. And then we had to overcome the parsing and matching capabilities problem. So I know what grants are out there, but I don't know what my capabilities are. I don't know what capabilities are missing that the grant also requires for. I don't know how to find someone to do that. So what happened was the developers, we did most of the testing ourselves very naively. And we determined that we were probably not the best people to do testing. It was probably the subject matter experts that know how to do the grants, that understand how the search works, understands what the capabilities are. They needed to be involved in testing. So this workflow is probably way too simplistic for something this complicated. There's no deterministic answer to this problem. There's no benchmarks you can do to prove your agent works. This is a subject matter expert has to look at this thing and say, yes, this is helping me, or no, it's not helping me. And you want to do that as early in the process as you can before you deploy this thing into production. So what we needed to do is quickly iterate on developing, deploying, and versioning agents, collaborating with subject matter experts who probably are not tech people. They know all about grants, but they don't know anything about agents. We also had problems picking out an appropriate LLM to do this. Some LLMs are better than others, obviously, for agentic work, and some of them are even better than others for working on a problem like this. And then ideally, the subject matter experts could do the above. So we would give them a control panel and say, flip these switches and drop these dials and turn it until it acts the way you want it to act, and then we can push this to production. So the first attempt to do this was we gave them a Colab notebook and said, see if you can use this. And that didn't go over very well because, like I said, they're not less on the technical side because they're subject matter experts. So the second attempt at this was we started another project called the Agent Lab UI. And the purpose of this is to quickly develop agents with subject matter experts in mind. So in the event that there is not a correct answer, this agent, it's not easy to prove whether or not this agent is working or not. The purpose of the lab is to allow subject matter experts and access to the agents before they're deployed into production, before you go any further in the process. So the new development pipeline kind of looks like this. Instead of going from the development into testing and then into production, we can iterate with this tool in order to bring the subject matter experts in and have them play with this ahead of time. And they can comment on, we think this works like this, we think this works better, and so on. So I'll just give a quick demo on this real quick if everything's working. All right, so I have the grant agents deployed. What I'm going to do real quick is I'm going to deploy a second agent so you can see how this works. Now picture you don't know anything about agents, you don't know anything about any of the stuff that was talked about earlier in this meeting, you just want something to work right. Okay, so what I'm going to do is I'm going to pick the platform to deploy it on. We'll pick Google, and then we'll call this, I'll just deploy the ISS one again, just so you see how that works. And we're going to use OpenAI, GPT 4.0, and then the system prompt is going to be basically your helpful assistant that helps people find space station. There you go. And then we're going to pick the tool out of the repository that we created before, and that is the ISS tool. Okay, and I'll deploy this. And while that's deploying, we'll go over and look at the grant agent. And right now, Google Cloud is having problems. Believe it or not, if this doesn't work, and it doesn't look like it is. Yeah, Firebase is having a problem right now. It's kind of working and kind of not. All right, so we'll call it a night here. If I can get this to work before the happy hour is over, I'll be happy to demo it. Oh, there it goes, just slow. Yeah, we won't wait for this. So, but the point of this is it allowed quick iteration on. Oh, okay, it's working. It's just this is very slow. Something is definitely wrong here. All right, but what happens here is someone that doesn't know a lot about agents can use this to dial the agent in a little bit tighter. And I did have, let's see if this works. We'll try one more thing and then we'll go to happy hour if that doesn't work. All right, so what we're gonna do is this is the grant agent right now. So the ISS one is loading and I don't know what's gonna happen with that, but the grant agent, the first thing I'm gonna do is I'm gonna upload a PDF of my capabilities. Oops, we gotta put that in the box. Stuff context. See if this works. So the idea here is I can upload my CV, page, link to my LinkedIn, something like that, and it should be able to figure out what my capabilities are. Yeah, this thing is not running right. Okay, there it is. It's just running very slow right now. Can please process PDF. Yeah, you don't know who you're upsetting here if you're not polite. All right, but what this will do is this will parse my resume and figure out, it'll write 9 or 10 queries about when I query the grant engine, what I should be querying it for. Yeah, this thing's just running slow. All right, let's go get happy hour. And then if anyone wants to see the rest of this, come find me and maybe this will be working by then. But normally this is instantaneous. I don't know. They're obviously having problems with Google right now. And this is all Firebase app right now that we have it deployed at. Has anyone else got problems with Firebase right now? Yeah. Okay, well, this one isn't my fault. This is the one demo that, that I blew that wasn't my fault. Thank you.
Does any of you have a fire question? Otherwise, over happy hour.
Yeah, I'll be around if anyone wants to talk.
Awesome. So thank you very much for joining. Yeah, I pass on.
Yeah, we just have a quick questionnaire to share with you to get feedback about tonight's meetup. And Ali's going to put it up. The second thing is the drinks are going to be on the 3rd floor. So you can take the stairs or elevator and we'll meet you there.
So if you can scan the QR code, basically the ideal process is that you scan the QR code and you answer while going to the 3rd floor. In this way, it will be really optimized. So thank you for your feedback.